Welcome to Digital and FinTech Analytics channel.
And then we will be going to the final part of the recommendation. So what's happening over here? Just I would like to explain it. So we will understand this part of the code with the help of a user uh, that will be passing through and uh, getting the recommendation corresponding to it. So we are passing a user 10106 from the test dataset, and we want to know what are the final predictions for this user uh, overall. So what happens over here? Let's get into the code. We are calling this final recommendation function, and we are passing it. It requires only the user ID. It has a parameter alpha 0.7. We will see like the usage of this parameter alpha in the later part of this code. Top k equal to 20 means like we want to recommend top 20 products, final top 20 products to this particular user ID 10106. Like for first from personalized insights point of view, there is a profile vector that we have for user ID is being printed. So if you see like from personalized insights point of view, the test set vectors for user ID 10106 is basically of the length 1 by 11997, which I have calculated earlier. And out of this 11,997, we can see like the user ID 10106 has interacted only with this much of item, and the rest are like zero. So that's what we see when we are calculating like this test set vectors dot non-zero. It will only return the uh, records which are having no non-zero values. So yeah, first what we are doing is like we are extracting the personalized profile vector corresponding to user ID 10106, and we are saving it in a list that we call as test set vectors, and then we are reshaping it into a 1 by 11997 record. Um, and we see like when we do a test vector dot shape, we can see like corresponding to user ID 10106, we have a personalized profile vector of the dimension 1 by 11997. And as we can see, uh, using this particular code, test set vectors dot non-zero. So what this basically written is like out of this numpy array, it will only return those records which are having non-zero values. So we can see the user ID 10106 have only interacted with this number of items out of the 11,997 items, which is like very common sense point of view. Like not every user will interact with all the items that is present in the database. A subset of the items are being interacted with. So we can see the items it has interacted with very few of the items. Now, now that was pretty much from the personalized insights point of view. Now we will look how the recommendations are coming from the collaborative filtering point of view. So over here, what we are doing is like first of all, we are getting all the users corresponding to user ID 10106 who have similar kind of purchasing pattern as compared to the user ID 10106. We created, if you remember, we created this mapping dictionary mapping over here, dict mapping nearest neighbor, where like for every user, yeah, for 10106, we have like these users who are having like similar kind of purchasing pattern from the training data set. So what we do over here in the next step is we get all the 5 users, since we are recommending like we are getting only 5 nearest neighbor, that is a hyperparameter you can play with and change uh, to get the better output. But like over here, like say like there are 5 users, we are getting as an output who are like having similar kind of purchasing pattern in the training data set as compared to the user ID 10106 in the test data set. So if you see the length of the users from the collaborative filtering, that is top 5 users recommended. If you see like over here, uh, where like the this is also the length of the users are like 5, and the and the and we can see over here length of users from collaborative filtering, that is top 5 users recommended, and the length of users is like yeah definitely 5, and these are the 5 users that are being recommended. that have these are the 5 users that have similar kind of purchasing pattern as compared to the user ID 10106 from the test dataset, and this is coming from the train dataset. Okay, again, like coming back to the code part, we have like 5 user, and corresponding to each user we have a personalized profile vector, which is of the shape of like 1 by 11,997. So corresponding to each of the user, what we are doing is like we are creating an array of array where for each of the 5 user we are collecting the purchasing profile vectors corresponding to each of the 5 user, and we are saving it in an array. So for each user, the purchasing profile vector is of dimension 1 by 11,997. So for all the 5 user, the purchasing profile vector will be 5 by 11,997. So that's what we are printing over here. Corresponding to each user, we have uh, this number of products in the recommendation, and the shape, final shape, is coming from this vector. So let's see. So corresponding to each users, we have 11,997 products coming as a recommendation. So there are like 5 users that are coming from the train data set, and corresponding to each of the 5 users, we will be having 5 by 11,997 dimension vector. Now what we'll be doing is like in the next step, we will combine all the 5 users recommendation into one. And for that, what we do is like we will sum up this particular array that we are getting via the axis 0. So, and we'll then normalize it by the number of users who have similar kind of purchasing pattern as compared to our test users in the as compared to our test users. So, which is basically 5. So, what this does is basically that 5 by, yeah. So this vector is this NP array train set here in this particular step has the dimension of 5 by 11,997. So we are reading that particular vector again to have the shape of 5 by 1 by.
11,997.
So let's understand this one with the help of the example that we were discussing. So this NP array train set, if you see, the NP array train set is like combining the purchasing profile vector of 5 users. So the dimension of this particular NP array train set is 5 by. You understand how we got this 5 by 11 997 vector? Because for each vector we have like around 5 users who are having similar kind of purchasing pattern as compared to our test user, and each of the user has a purchasing profile vector of the dimension 1 by 11997. So when we stack up all these 5 different times, then the final vector that we get will be of the dimension 5 by 11997. Okay, until this we are clear. Now what we are doing over here is like we are summing it up. So before summing it up, what we are doing is like we are reshaping this particular array uh, because we will be summing it up later. So we are reshaping this array into 5 by 1 by 11997. And once we have reshaped it, then in the next step what we are doing is like we are in this particular step where like you see, right, x is equal to 0, and we are summing it up, input dot sum, and the x is equal to 0. So what it is doing is like along the x is equal to 0, which is like 0th axis, this is like the 0th dimension, this is the first dimension, and this is the second dimension. So along the 0th axis we are summing it up. So basically when we sum it up, the final vector that we'll be getting will be of the dimension 1 by 1 by 11997, or like in other words, it is like 1 by 11997. Okay, so that's what we are getting it as an output of sum set final. Okay, and yeah, let's see, like combining, or when we are combining the sum, when we are summing it up, and also like after summing it up, generally we do the normalization, right? So it is also divided by the number of users, that is like 5 users. So it is divided by 5. So it's a normalization step. And finally, we will be getting the final vector. So let's see the output. So yeah, combining all the 5 users recommendation into one, we have got 1 by 11,997 vector corresponding to the 5 users recommendation. So over here, I would like to take a pause and explain like this vector that we are getting, which is of the shape of like 1 by 11997, and we are getting it after summing up the 5 users profiling vectors. So so what do you think like this vector represents? So each of the non-zero values in this particular vector represents like the items from the collaborative point of view. From collaborative point of view, collaboration of like this 5 users, which are the items that are having like high weight value in this particular arrays, uh, su- suggest like those are the items that when recommended to user ID in the test dataset gives the correct final prediction. So what collaborative filtering does is basically it will take a user ID from the test dataset, and corresponding to that user ID from the test dataset, what it does is it will find the similar uh, purchasing pattern users in the train dataset, and then it will look into the uh, it will create a vector which will basically look into the purchasing pattern of this 5 user in the from the train dataset, and the collaborate then it will summarize it in a single vector, and the items that are having like highest weight in this single vector will be recommended back to the users in the test dataset. So that's how like this collaborative filtering works overall. So so finally, when we are having like the recommendation from the collaborative filtering and the recommendation that is coming from the personalized uh, point of view, personalized insights point of view, finally we have to combine these two into one single vector. So what we do over here is like we'll be giving some weightage to the personalized profile vectors and some weightage to the collaborative vectors. This weightage is like denoted by alpha, which is like 0.7 in this particular case. But again, this is like hyperparameter, and you can play with and see like which hyperparameter suits best in your use case. So what we do is like we uh, we will be giving some weightage, like I can explain it over here. So we have a hyperparameter alpha. Um, Hyperparameter. It is used to bring a balance between the collaborative and the personalized insights. So what we do over here is like we give the final predictions as alpha times like the personalized insights plus 1 minus alpha times the collaborative insights. So if you see alpha, say like alpha is in our case is 70.7. So we are giving 70% weightage to the personalized to the recommendation that is coming from personalized insights point of view, and 30% weightage is being given to the recommendation that is coming from collaborative insights point of view. Again over here I just want to repeat over here. Here like the collaborative insights, the vector that is coming from the collaborative insights is of the dimension 1 by 11,997, and the vector that is coming from the personalized insights is having like the vector of 1 by 11,997. So even if after multiplying this 70.7 weightage to this and after multiplying the point 3 weightage to this collaborative insights, we will be adding these two, and the final vector that we'll be getting, that will be also having, this is like element wise addition. So the final vector that we'll be getting, that is also will be having the dimension of 1 by 11,997. And out of this final vector, the 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 product IDs or the indices that will be having the highest weightage will be finally recommended to the user from the test dataset. So that is like the final recommendation. So over here also what we do is like we will be sorting this vector in descending order, and the arguments or like the indices that is having the highest that carries the highest weightage will be recommended to the user from the in the test data set. So let's see the same thing in the code itself. So what's happening over here is like here, as I was mentioning, we are giving like 70% of the weightage to the test set vectors, and 30% of the weightage to the collaborative vectors. That's what we can see over here. So 70% is being given to the personalized profile vectors, and 30% weightage is being given to the collaborative vector. And then we are summing it up. We are summing it up, and finally, what we are recommending is coming from here. So we are recommending the top 20 items. Okay, but how we are recommending is like we are this final predictions vector is like in combined. So we are taking that combined. It's an array of array. So the inner array contains all the list of vector. So we are indexing it by using 0 and getting that inner array. And this arc sort basically um, arranges the array in ascending order, and the items which are having like the uh, least weightage is in like the initial part of the array, and the item which are having the most weightage is in the uh, last part of the array. So when we are reversing that array using this colon colon minus one, we'll be reversing that array such that the items with the so the product IDs with the highest weightage comes on the first part of the array, and the product IDs with the lowest weightage comes on the last part of the array. And then we are reshaping it to have only one single dimension so that it is easy to extract the top 20 items having the highest weightage from the final predictions. And that label list is basically returned and recommended to the users in the test dataset. So if you see over here, uh, so out of the 11,997 items, we recommend that top 20 items at position which are coming from this position. And as we remember in the initial part of the course I have discussed, each position ID represent a distinct product ID. So position ID 556 means like product ID 556, 8843, and so on and so forth. The top 20 products are being recommended to the user 10106. So that's pretty much on how we do that. So this is what I explained it for a single user, but we will be doing it for all the users in the test data set by calling the final recommendation function and passing the user ID, and it will calculate the final recommendation, the top 20 final recommendation. And that's how like the whole of the recommendation system engine works. And we recommend all the users in the test data set the most likely product that they are going to buy. uh, so that's how the recommendation system works. In the next upcoming session, we will be discussing basically on the basis of what metrics we judge the quality of this model.
That's a wrap for today's video. If you found this content valuable, make sure to hit that like button and subscribe to the channel so you don't miss out on future insights into data science, AI, machine learning, and analytics. Looking to master data science or drive data-driven success? I offer expert training, mentorship, and consultancy for individuals and organizations. Let's collaborate. Reach out via my contact details in the bio.